All right, I have a lot of material to cover, so I'm going to try to get started. I like it a lot when speakers have their slides available, and there are a fair number of code examples. So if you go to tinyurl.com, SD15lint, Scala days 15 lint, you'll have my slides. You can walk out and go to a better talk now, or you'll be able to see the answers to my pop quizzes and make me feel like I have a smart audience. So either way, that'd be great. I'm Leif Wickland. I work at Oracle. Before that, I worked at Right Now Technologies, and then we got acquired by Oracle. I've been doing Scala for about 4 years. We've been building big data systems and various things like that. So what is static analysis? It's scrutinizing code to find errors ahead of time. You're here at Scala Days, not at JSConf, so I assume that you like to be told when your code's wrong as early as possible. I know I like to. So that's the kind of thing that we're trying to accomplish here. It's not exactly the compiler's job to do these things for you. The compiler's there to convert your code to something executable. So we're talking about additional tools beyond what the compiler does there to help you find problems. For some reason, I can't seem to advance. There we go. So why the static analysis? I think Scala C allows you to do some things that demo really well but aren't a good idea in production. We'll have some examples of that in a bit. You probably have a coding standard. I think a coding standard that isn't automatically and uniformly enforced isn't a good idea. It's just a suggestion. I think you should have code review, but I think there are a lot of elements of code review that can be done automatically and have greater wisdom applied than your team probably collectively has. So we're going to use static analysis to get you a better compiler, such as we're going to stop inferring any, and we're going to notice when we forget to do string interpolation correctly. We're going to get you more hygienic code so that you don't have to argue in code review about how things should be indented. We're going to get you higher quality code so you ship fewer bugs. And yeah. More specifically, we're not going to ship bugs. So we'll talk about all of these things in a bit. There are a lot of options in Scala ecosystem now for static analysis. I'm really thankful for the authors that have done this. I'm going to pick some winners and losers. That isn't to say that I think the tools are bad. That's to say I think some are better than others, but I'm really thankful that we have so many to choose from nowadays. So your IDE will probably do some amount of static analysis. I don't think that's what your team should be depending on, because you'll probably end up with something inconsistent because not everybody, I hope, uses the same thing. I hope you don't have that monoculture there. And I think it's important for these sorts of checks to be built into your release process. So while it's very nice that your IDE can do that, I say that's not the right solution. There are some web-based UIs that do static analysis. They don't really fit my biases. I think the analysis ought to be in your build and release process, and these things sort of sit on the side. They are very pretty. They have very nice reporting. But I'm really not going to consider these tools at this point. Maybe if you were dealing with a project that had a mixture of languages, it might be more important to use a tool like this, but again, this isn't what I'm going to evaluate. These aren't my biases. So how I am going to evaluate the tools is look at how much value they give you for the spurious results that you end up getting. When you do get a spurious result, you need the ability, I think, to tell the tool it's not a big deal. So we need suppression ability. And then how hard it is to get going. What's the learning curve to get up to speed? I'm going to give each of those categories a red, blue, red, yellow, green ranking. I'm just making it up as I go. And as it turns out, the things that I think are best aren't the ones that get the best ranking. So we'll go with it. So back in 2013, this nice gentleman tweeted at Scala that it was drunk go home because of this bit of code. He's got an object, he sets one value equal to another, initializes the second value, and then what does Scala print when you're done? It prints 0, right? Because B wasn't set to anything but the default value when you initialized A to it. You know, and this is just one of those haha, Scala's a funny language sorts of things, right? Well, we can do better than that. Scala has given us the ability to recognize uninitialized values. The bad news is that it's a warning, and you only see warnings when you do a clean build of your project or you change the file in which that warning appears. And this is a bug I don't want to ship, right? I mean, I want this to go away and not be possible. So what to do? Well, Seth Tissue recommends turn on X fatal warnings. And I think, and Seth thinks, that if you have a well-managed project, you're going to have X fatal warnings turned on. And if that's the case, then when Scala reports an error, a warning here, you're actually going to get an error, and your build isn't going to happen. So to do that, in SBT, you'd add a line like this. Moving on. Here's another example of some code. This code compiles. What does it do? It always returns false. We've created a set, and then we're looking in that set for the unit value, which is never there. Well, this isn't good. Why is that happening? It's because Scala allows the arguments to be adapted, and it's seeing those parentheses, like I say, as an instance of the unit value instead of the parentheses that you probably meant to put a value inside of. So a similar thing here. We've got a list, and it looks like we're turning it into a set. In fact, that's not quite what we're doing. What we're really doing is we've got a list that we're turning into a set, and then we're calling the set's apply to see if the unit value is in there. And again, you're always going to get false here instead of something useful. So we can do better than that. We can ask Scala not to help us that much, and in fact to tell us that we've done something wrong. In 2.10, this behavior was deprecated, but the only thing that happens with that deprecation is it prints this message, rerun with deprecation for details. You're like, I don't know, how do I do that, right? So the other problem is that deprecation is only a warning, so you're only going to see it the first time you modify that file or on a clean build. And again, that's not the kind of thing I want to ship. So in addition to saying X fatal warnings, I think you ought to add that -deprecation to your Scala C options. So one downside of this is that if you have libraries that you depend on and you're calling methods in them which are deprecated, this -deprecated flag applies to them. And if we got fatal warnings, then it means that calling deprecated code in libraries is going to break your build. Now, I'm not entirely sure that's a bad thing. I think it's nice, but be aware that this has a consequence that will probably make you clean up your project and make it a better thing. Here's a little bit of code. What does this do? It throws an exception, right? I mean, it compiles beautifully, and I ship it, and when my code is breaking, instead of getting an error to tell me what I did wrong, I get an exception that takes down my program, right? This isn't what I want, because I've passed the wrong number of arguments to format. And I hate sprintf or printf style things because they typically have this problem. The good news is Scala gave us string interpolation fairly recently. So now we can do this kind of thing instead in Scala. What happens when I run this code? I forgot the S's on the front of my strings. So now I ship these lovely logging messages and instead I see $signs, right? Now I just have more problems because I can make mistakes in new and different and specialer ways. All right, so there's another switch you can add to Scala C, xlint, so that when you do something like this, among many other things, it'll warn you forgot the interpolator, the S on the front. So xlint, deprecation, and fatal warnings, I think ought to be in your Scala build. In 2.11.4, Scala made it possible to selectively enable bits of the xlint. There are quite a few checks that does. So if you have an existing project, that's important to you because it's entirely possible, and I'm not trying to cast aspersions and say you write bad code, but it's possible that you'll get a whole lot of warnings. And if you want to take your time, then you can use this selective bit to enable parts of it incrementally so that you can clean up your project in maybe a few iterations. What happens when I compile this here code? Well, the answer is nothing good, right? I've accidentally stuck a C in with my A and B, which are members of an ADT, and it's going to compile just fine, which isn't what I want. I've made a mistake. The compiler is going to go and infer any for us. And probably somewhere down the line when I try to map over this sequence or whatever, I'll get some weird message that doesn't make a lot of sense to me. Here's another piece of code where I'm doing something similar. I have a sequence of integers, a sequence of strings, I'm jamming them together into a new sequence to produce the cross product. And instead of a compiler message warning me that I've done something dumb, it happily infers a sequence of any for that for the cross product sequence. This isn't what I want. So if you enable excellent, like I was talking about, you get this message. And this is one of my favorite messages to see because it's just saved me 5 minutes trying to figure out what I did wrong. So again, I really recommend you enable excellent, X deprecation, and X fatal warnings. So my summary on Scala C switches is I think they do a great job. I don't get very many false positives with them. Their value seems really high to me. There's not a good way to tell the compiler, like, don't do that thing. If you really do need a sequence of any, you can explicitly put a type on it, but you know, there is no suppression, so I can't give it a green on that. The documentation on these things is somewhat lacking. It's hard to know exactly what it is that the switches you're enabling are going to do for you, so the learning curve's a little steep. You might be objecting and say, I have an open source project that is targeting multiple versions of Scala, and not all of these switches are available for all the versions that I use. I wasn't that smart. One of the times I gave this talk, Stephen Kampal asked me this question, and I stammered and said, I don't know. And then somebody piped up from the back of the room and said, well, all you have to do is only enable those switches for the latest version of Scala that you're targeting. All right, moving on to some of the other static analysis tools. In his keynote last night, Martin mentioned find bugs, and that it struggled with some of the synthetic code which was generated. Well, anyway, find bugs is this old tool for Java that does static analysis. It came out of the University of Maryland. And I agree with Martin. It doesn't do well. It has a high false positive rate. I'm going to give it, you know, essentially the worst ranking of it's so bad I ran away immediately. It gave me no value. And that's not surprising. It's a Java tool. It wasn't built to be agnostic of language. Moving on, there's another tool called Scala Style. As the name implies, it's oriented towards style. It uses Scalariform's parser, so that has some interesting consequences. Most of these things are plugins to Scala C. So they track along fairly closely with the development of that. Scala Style lagged behind, for example, when string interpolation was added because it required some changes to its parser. Another benefit of this is that it allows it to run relatively quickly on my large project compared to things that depend on being in the Scala compiler. But it doesn't have the full type information that these other things do. It's easy to get into your project. There's just an SBT plugin that you stick in there, and I believe there are other integrations for other editors. Martin's class on Coursera has used this in the past to help people identify sort of better Java ways of writing Scala that they shouldn't be doing. It's a mature and a well-documented project. You configure it via XML. If I haven't lost you yet by mentioning XML, then you can start with a very accepting configuration and slowly dial it down, which I like. So you can say, well, now I don't want to allow my code to include null anywhere. Or I want to say my files can only be 750 lines long. That sort of thing. And again, I think this is important if you're bringing it to an existing project so that you can slowly tighten the screws down. If there's a place that you have to interface with a Java API that like makes you use null because that's just the way people write Java, then you can put comments around the line that tell Scala Style to bug off and let me do the bad thing I need to do. A while back, some folks published a proposed coding standard for Scala, and their very first rule in their 0.1 was don't just blindly follow these rules. Right? Well, I think that's true here. Like in general, I don't want to see null in my Scala code, but sometimes I have to. So I think tools need to make it possible to say I have to break the rules here. Scala Style also has a shorter form of suppression where you can just do it on one line like so. In general, I'm going to break the Scala style rule set down into 3 areas. Various things around coding standard, like the length of your files and your functions, cyclomatic complexity, the length of your argument list, how many parameters it takes, that sort of thing. Indentation, not just blindly using magic numbers without assigning them a symbolic name, that sort of thing. Banning better Java, don't use null, don't use var, don't use the return keyword explicitly, don't use while, don't call clone methods, that kind of thing. And then good practices. So some custom rules that we've added to Scala style are to preclude shipping the triple question mark and print line, because typically most of my tools I have no reason to write to standard out, or not my tools, but like my web server probably shouldn't be explicitly writing to standard out because I'm not a CGI. Okay, maybe that one didn't land. And I don't really want to ship not implemented stuff most of the time. So these are, quick little checks that we can add. So like I mentioned, we were able to add those kinds of things. We did it by adding regular expressions to the configuration. You can also add more complicated rules, but it's fairly complicated and cumbersome. I've provided a link there if you're curious. So the rule set is pretty broad for Scala style. Sometimes it'll include rules on both sides. So you can require spaces around operators, for example, or you can require that there not be spaces around an operator. In summary, I feel like the signal to noise gets a yellow because there's the sorts of things you can check here aren't like massive bugs that are going to bring you down probably, but they're definitely nice to have in terms of making your code base more hygienic and more consistent. And it can generate false positives, right? Sometimes you have to use null, but it's got really nice suppression that's well documented to deal with that. And finally, it's fairly easy to get going. My biggest frustration is that the suppression is sometimes hard to line up with the error message it gives you and how you have to do that suppression. So when I showed you the example with null, you have to guess from the null is banned that you then should say Scala style off null specifically. If you have a coding standard, do you guys have coding standards? Right? Well, that's fewer people than I would have guessed, but I think a coding standard that's not uniformly and automatically executed is more of like a philosophy document or suggestions. I think your coding standard should be uniformly applied so that you actually have a coding standard. I've been on teams that have written PHP and C# and C, and until you actually get to the place that they're automatically enforced, it's not a personal matter, then you don't really have a coding standard, you have a vehicle for people mistreating each other. And like, you're doing it wrong, I'm pissed at you for some reason, right? Just take the emotion out of it and make code that breaks your build, essentially, if it doesn't conform to the right rules. In related news, there's a tool called Scalariform, which has an SBT plugin, and it will automatically reformat your code. This isn't really a piece of static analysis, it's just a good way to avoid arguments as far as I'm concerned. I don't have much nice to say about the Go programming language, but I think one of the things that they did really nice there is that there's a canonical formatting defined, there's a tool shipped to do that formatting, and then the community has embraced that there's just this way that we're all going to format our code. And so you don't end up with like the forever debates of where do curly braces go on the next line or this, that sort of thing. There's just one way it's done and we all move on, and we don't have petty code review arguments about should this be indented this way or that way. So just as a bonus, I really like Scalariform and I recommend you use it. Moving on, there's a tool called Abide. The nice people that are working on that are here in the room. It's not yet released. It's at the 0.1 snapshot stage. 0.1 snapshot, anyway. The documentation is still a work in progress. They've been working on it. It's sponsored by TypeSafe, is that fair to say? Yeah. Okay. So the rules have a pretty mainstream flavor. For example, the rule to ban vars applies to public contexts. Ironically, I thought I had found all my vars in my code and either blessed them or not, and I ran Abide and it found a couple that we had not taken care of like we needed to. It supposedly will detect if you have a var instead of a val, that could be a val, that is, something you assign to a var and then never change the value of. It detects unused locals. I ran that. It found some that we weren't using, which was nice because it meant I had some dead code in places that I wanted to get rid of, and it wasn't being detected by my other tools. It found some false positives that I suspect they'll address soon. It has some ACA-specific rules, and it looks like there's some work to move some of the stuff. I don't know if that's true, if you guys are moving some of that stuff into here from xlint or -y.
Yeah, that was the intention.
Okay.
See if a bite can actually take that thing out of the compiler, simplify the compiler, and have some of this easier to turn on and off eventually.
I defer to his expertise. So I'm not going to judge a byte at this point. It's unreleased, but I think you should be aware of it, and it's a good tool that's coming along. Here's another piece of code. What happens when we compile this mess? What's that? Oh yes, yes. We infer a sequence of product, because I accidentally created one string on the top and two strings on the bottom, so I've got tuple 2 on top and tuple 3 on bottom, and our our type inference seeks down and finds that they share product in their ancestry. And really, it's worse than that. It's a sequence of product with serializable that it finds. Wart Remover is another static analysis tool. It will find this for you, among other things. It was written by Brian McKenna, and other people have contributed to it. It seems to have a low false positive rate for the things that I want it to do. It's well documented. It has nice SBT integration. And I've actually used the extensibility for this one. It was fairly easy to do and reasonably well documented. It has suppression built in. One thing I don't particularly like about Wart Remover is that the suppression is done at a file level. So either you believe in everything that you've asked Wart Remover to do for the whole file, or you get no analysis. And I'd prefer finer grained than that, but this is how you do it. I'm going to group its capabilities into 3 categories. Avoiding problematic inference, so like product, serializable, nothing, and any. I don't particularly believe in the nothing check, because that tends to have more nuisance, generate more nuisance than I think it does value. It bans better Java. This is a lot like the list of things that Scala style does, but it has an option to also ban throwing, entirely banning throwing, which it doesn't really work in the world that I play in, because Hadoop, essentially. I'm working with Java, and sometimes you just have to throw. And then it gives you a way to ban partial methods which throw if the underlying object is in the wrong mood. On my team, we call those methods like head on a list, the YOLO methods, right? It's sort of the idea that I'm going to hedonistically write this code, damning the consequences for the future. You only live once. And you know, for a while we were just ironically putting / YOLO after calling list.head, that kind of thing. I was wandering around Vienna, and I saw this sweatshirt in a store window, and I thought, well, the designer certainly meant it like, you know, with a period after those first 2 words, telling the viewer what they thought of them and that they're leading a much better life for the present. But I would much rather have a comma there addressing the YOLO methods and telling them that I think they're worthless, because those kind of methods that are happy to blow up, if you catch them in the wrong mood, really seem like, you know, not an optimal way to go. I would rather see you call head option on a list and deal with the fact that, oh, it's empty, or, you know, if I reduce a list, I would rather not get an exception if the list happened to be empty. I'd rather have to think through what should the default value be if I reduce it. By default, Wart Remover turns off all of its values. Essentially, you can include Wart Remover and it will do nothing. If you want to turn it on, you can do this. I would rather do something more like this, where you're just turning on a small subset. I have an example I'll talk about later that shows you the things that I'd particularly include. So in general, I like Wart Remover a lot. I feel like it gives a lot of value for the false positives that it generates if you choose the correct set of things. I don't love its suppression, like I mentioned. It's clear how to do it, but it doesn't give you fine-grained control. And the documentation is good. It's pretty easy to get it running on your stuff. It's very opinionated. Brian McKenna comes from the Haskell Later camp of Scala. So if you want to write Haskell Later, then you can turn all the dials on this way up and you'll be in that camp. It's pretty slow to run on my project. To run it on 30,000 lines of code takes like 8 minutes. Yeah, anyway, it takes a while, let's say. So my recommendation is to have a separate build target for that, and I think that works just fine. Go ahead.
I also had problems running the whole code because it crashed when I ran against the code that I was reviewing.
Fascinating. How recently, sorry, so he said he had problems with Wart Remover because it crashed when he ran it on the code that was being analyzed. How recently did you have that problem?
This was like 2 months ago.
Okay. Did you write a GitHub issue against that?
It wasn't my code that I was
Gotcha.
reviewing, so I couldn't really provide sample.
Gotcha. Okay. I've got another piece of code here that doesn't do exactly what you wish it would. Do you have any suggestions on what that might be? No, for a change, I'm not talking about inference. Not quite, no. This one's more subtle. So when you call split on a string, you get back an array. And when you create this error message here, it's utterly useless because the toString that you're calling there by concatenating to bad is the Java library's toString, which gives you something horrifying like right square bracket L string at hash. That doesn't help you at all, and you don't find out until you need it the most, right? This isn't something I want to allow. What could we do better here? So here we've got a list, and I'm calling length on it. As you'll recall from CS, the time complexity on the length of a list is linear. So I had code not entirely dissimilar from this that I was calling for every member of a list, and I turned what should have been a big O n problem into an n squared problem because I was using length instead of checking if it was empty, when all I cared about was if it was empty. So there's a tool called linter, maybe not the best name, not the best branding, that will detect these as well as many other things. Its history is pretty long. As far as I can tell, it was originally an internal tool at Foursquare. A guy named Jorge Ortiz, who used to work there, tried to extract the generic bits of that and open source that in 2012. A few people have picked it up and poked at it over the years. And then another gentleman is maintaining the current fork of it, and I can't say his name, I'm sorry. I just call him Harry Fodder based on his Twitter handle. The documentation's kind of middling. Some of the checks are documented, some of the checks have links to the unit tests, and you can sort of suss out what the intention of the test is. And some have no documentation, and you guess from the name what it does. It's a Scala C plugin, but there's not an SBT plugin, so you needed a little bit of additional knowledge to be able to configure it. Specifically, you use switches to Scala C. It has even more rules than Scala style. Those rules are pretty good. I feel like there's a lot of wisdom in those rules, but like I mentioned, it's kind of hard to figure out what they're going to be doing. By default, all of those rules are enabled. They tend towards more of what you would think of as linter if you have a history with other lint tools. These things we are looking at here aren't making your compiler better, they're helping you find very subtle things in your code that you're going to regret later. And because it has so many rules, it's easy to be overwhelmed by it, I think. So here's a partial list of areas in my code that it identified that sucked. I was calling string.format with some mismatched args, like we talked about earlier, that's going to throw on us. I had unused function arguments. I was using length on a list. I was forgetting to close a Scala source. Let's see. When I was first writing Scala, I would cast between numeric types instead of calling 2-byte or something like that. We tend to end up with 2map or 2list on the end of a long, complicated set of filters and maps, and sometimes we'll have done it wrong, and we'll be converting something to a list that was already a list, and it'll detect that for us. And then using the relatively, I'm not sure, they're not explicitly deprecated, but the converters that implicitly convert Java collections instead of using the explicit Java conversions. Sorry, I have that backwards, don't I? Perversion, converters, whatever. Anyway, it tells you when you use the wrong one of those two, and I can never remember which one it is because I've outsourced that part of my brain to a tool. Like I complained about earlier, the documentation is somewhat incomplete. I definitely think it has value. It found real bugs in my code that would have exploded. Very low false positive rate, I'm happy with that. You can suppress it in code, it's really a pain. It's kind of like the problem with Scala style where you get one error message and then you have to try and figure out from that what the internal name of the error is from the incomplete documentation if you want to be able to suppress it. I wish there were better documentation. I wish that somebody would figure out, it probably should have been me, but it wasn't, maybe 10% of all the checks that are most valuable and most likely to help you find bugs, just so that if you're applying this to an existing project, you don't get overwhelmed by so much noise. And I wish there were an SBT plugin to make it slightly easier to get going. So I think there's a lot of value in the signal to noise ratio. Like I said, the suppression's a pain, and the learning curve is kind of steep. What could we do better with this code? Right. Here, instead of calling two methods, we could just check if there exists a member of the collection that's greater than 42. Kind of like that. What could we do better here, potentially? Sorry? Yes, right. We can depend on universal equality to help us find that member in the sequence without writing a lambda to do it. So there's a tool called Scapegoat. It found things like this in my code base. A guy named Stephen Samuel started that development. It was about a bit over a year old. It looks like development effort has tailed off since August, but it was a very ambitious project. It has good documentation. The suppression is kind of like Wart removers, where you are suppressing whole files and you can't select which rules get suppressed. Like I say, it's ambitious. It tries to do just a tremendous amount. I mean, if I were to summarize, its rule set looks like Wart remover, linter, and Scala style all combined. Things that I found in my code base, like we talked about, using exists instead of a more complicated approach. I accidentally typed sealed on a class one time instead of final like I meant to type. It identified that to help me find what I'd done wrong. Looking for length of 0 instead of is empty. It finds vars that could be vowels. It identified duplicated imports. Unused method parameters and the contains instead of exists like we talked about. I don't like it because it's overwhelming. I mean, it just implements so many rules that it it's hard to cope with. It had a pretty high false positive rate. I believe I wrote some of those up and sent them to the nice folks 6 months back, and I didn't hear anything about it, but it was after all the activity of development had tailed off. It bans some things that I don't think should be banned. For example, it bans making a case class final under the mistaken impression that case classes are already final. It bans wildcard imports, but if you do that, I don't know how you bedazzle your classes with additional methods, however you like to describe that pattern of using an implicit class to add methods to objects you don't own. So I kind of give this a middling grade. I think it would be interesting if somebody picked it up and worked further on it, but yeah, that's where that's at. More code that doesn't work right. What is it? No, it's not 10, it's false. When you compare arrays to each other in Java land, you get the equality that the Java library provided you, which is always false. So this isn't terribly helpful. I mean, this is like PHP level nonsense of things that you would expect to be equal or not equal or vice versa. So there's a relatively new tool out called Artemis SuperSafe. I believe your swag bag included a paper airplane piece of paper from these nice folks. It came from the nice people that made Scala test, Bill Venners and so forth. That's a tool I love and use a lot. This tool is a commercial one as opposed to Scala test. It's $60 per year per user, and the first version just came out in January. So far the rule set's pretty small. It's focused on a variety of problems of equality. It also has a rule for the suspicious inference, the any and the product, that sort of thing that we talked about earlier. It currently doesn't have support to suppress things. That's because they intend that it will just not have false positives. I ran it, I found a false positive, I reported it, they got it fixed by the next morning, but all the same, I think tools probably should have suppression. And I was impressed. It didn't have a lot of effect on the build time of my project when I added it in, which I really didn't expect for a Scala C plugin. So because it's a commercial product, I expect it to have like really high value, not so much because of the money, but because of the effort to go through to annually renew a procurement. At least for me, that's always been a tremendous hassle. So I want it to have more signal. I want it to give us more value. And I don't feel like it's quite there yet. But I know Bill's looking for people who will help him guide his product in a particular direction to be more valuable. So I expect it to improve. It doesn't have suppression, like I say. The documentation's kind of middling. There's one really long web page that lists all these things. So in summary, here's what I had for all those things. And looking at my colors here, you might think that Wart Remover is my beloved, and it is not quite how it sits, but I would say you should definitely go home and enable the Scala C switches like we talked about. If you're interested in having a coding standard, then I think that should be implemented through Scala style. Because they're slow, I think you should consider having Wart Remover and linter in a separate target, because they do add value, they do find real bugs, but I don't think I want that in my compile loop, but I probably want it in my build release process. And I think it's a good idea to keep an eye on things like SuperSafe, Abide, and Scapegoat, because they very well may turn into very good projects. So if you've got a new project, I would have you turn on the Scala C switches like we talked about. I stole stuff from Rob Norris, who's running around here somewhere, and adapted that to say, here's the set of, I think, 8 things that you ought to have turned on. And I have a project that will show you all this stuff in a bit. You should have a Scala-style coding standard and have a separate build target like we talked about for these tools. There are some Scala C switches that are too slow to use most of the time. For example, you can identify unused imports that way, so you can toss that into your lint build target. I made a skeleton project on GitHub that you can get to at this URL, tinyurl.com lint-scale, like skeleton, that shows you how to import all those projects and set up a separate lint target that you can run things inside of. If you have an existing project, then I encourage you to go back and try to add some of these things to it. I mean, don't try to do it all at once because, again, no offense, but I suspect you're going to be overwhelmed if you have a non-trivial code base with the number of things they complain about. There's a book called The Pragmatic Programmer that discusses how to become a better software craftsman. And one of the things it discusses is the idea of the broken windows theory as applied to software. The broken windows theory is that, a neighborhood stays fairly nice until something like a window gets broken and nobody fixes it. And then somehow the morale of the neighborhood just rapidly degrades and people are willing to let other things go to pot. Their recommendation is don't live with broken windows. I feel like if you have a code base that you compile and it spews out hundreds of warnings, you have lots of broken windows, and there's not an incentive for your team to say, oh, I added code that created another warning, right? Don't live in an environment like that. Clean that up and get stuff fixed so that you can identify that there's something that's gone wrong. One broken window is like, oh wow, that's, something happened. 100 broken windows plus one more is unnoticeable. So if you hear nothing else, go home, enable these switches in Scala C. Like I said, my slides are available at tinyurl Scala Days SD15 lint. And do you have any other questions? Go ahead.
Yeah, there is an early stage Sonar Q plugin for Scala. I'm just wondering if you have experience with that.
Sorry, so the question was, there's an early stage Sonar Q plugin for Scala C? For Scala. I don't know what Sonar Q is.
Sonar Q is an analysis aggregator, if you will.
Oh, okay.
That allows you to take out input from all different rules and all different languages and so forth, and be able to put some sort of compliance layer on top of it, so like disable whatever you want. If it full produces it, you can ignore it.
Gotcha. It's a tool that aggregates warnings from various static analysis things and allows you to disable them individually. I don't know anything about it, sorry.
How would you rate the ones that you recommend for extensibility?
Right, okay, so the question is how would I rate these tools for extensibility? The question is what do you need to do with your extensibility? So if you need types to do your analysis, then you'd probably be looking at something like a byte or Wart Remover for extensibility. If you just want custom bits around how long things are or what can appear that doesn't depend on types, you can probably do that with Scala style. Yes? Scalera form is based on a particular parser of the Scala language that's not the standard one, and both Scalera form and Scala style use that parser. Thanks for coming.